Hi, today we're going to take a look at section 10.3, day number 2. And this section, as you can see, is on multiplying radicals. Now, multiplying radicals is a little bit different than adding and subtracting. We know from the previous lesson, when we add and subtract radicals, we have to have like terms. The radicals have to be the same. But with multiplying radicals, they do not have to be the same. For example, if I had 2 square roots of 3 times 4 square roots of 5. With multiplying radicals, the key to this is we multiply big numbers with big numbers. 2 times 4 is 8. And then the numbers under the radical with other numbers under the radical. 3 times 5 is 15. 8 square roots of 15. Now, very similar to when you did fractions with multiplying fractions, you should always check this leftover part under the radical to see if it can be simplified. Okay, now 15 has some factors, but again, if you look at your factor sheet, does it have any factors that are perfect squares that are highlighted in black? No, it does not. And there's our answer right there. Okay, but the whole key to multiplying, there's 2 things with multiplying radicals. Number 1, you can only multiply big numbers with big numbers, radicals with radicals. And the second part is once you combine the stuff under the radical, always check to see if it can be reduced. Okay? All right, we're going to take a look at a couple others here real quick. How about 4 square roots of 6 times 5 square roots of 2? Okay, if I multiply the big pieces together, 4 times 5 is 20. If I multiply the radical pieces together, I get the square root of 12. Now this time though, the square root of 12 can be simplified. And again, to make it simple, just look at your factor sheet. Does 12 have any factors that are highlighted in black? Yep, there's 2 of them. 4 times 3. The square root of 4 is 2. And then just remember we multiply it by the number out in front. 20 times 2 is 40 with the square root of 3 left over. Okay, so we're still going to have to reduce the radicals, but this time it doesn't happen until the end. Okay, but multiply first and then reduce. Okay, let's take a look at a couple others. Okay, how about these? Okay, if I do the big pieces together, 2 times 7 is 14. The radical pieces together, 6 times 3 is 18. And I know on my factor sheet, if I look, it's 9 times 2 is 18. The square root of 9 is 3. And then I have to multiply it by the number out in front. And 14 times 3 is 42. With the square root of 2. Oops, with the square root of 2. And there's my answer right there. And I did that multiplying kind of fast. Okay, but take your time, let your calculator help you. Okay, if I do these 2, if I multiply those 2, the big numbers, 9 times 11 is 99. 15 times 5 is 75. Okay, now 75 is not a perfect square. And if you look at your factor sheet, the 2 in black are 25 times 3. There's 3 quarters and 75 cents. The square root of 25 is 5. And oh boy, here we get a big number. 99 times 5. And again, it's a calculator problem for me. 495. With a square root of 3 left over. Okay? So, I'm hoping it's not too terribly bad. Okay? Just make sure once you multiply the radical part together, simplify it if you can. Okay? Before I get to that, I want to mention a couple things here. Watch this. See if we can come up with some patterns. The square root of 2 times the square root of 2. What if it's just a radical piece? Yep, that's the square root of 4, and the square root of 4 is 2. Okay, watch this one. The square root of 5 times the square root of 5 is the square root of 25 if I multiply them together. Well, the square root of 25 is 5. And this one was 2. Have you seen any patterns? How about the square root of 3 times the square root of 3 is the square root of 9, and the square root of 9 is 3. Okay? Are you seeing any patterns from here to here without having to do that middle step? The square root of 5 times the square root of 5 is just plain old 5. The square root of 2 times the square root of 2 is just plain old 2. Yeah, there's a little bit of a shortcut there if you want to think of it as that. Okay? If I have 2 radicals that are exactly the same, and I multiply them together, the answer is just that number. Okay? I'm going to hope that you can maybe use that little shortcut, which is going to eliminate this in-between step. Just maybe save you a little bit of work. For example, the square root of 7 times the square root of 7 is just big 7. The square root of 812 times the square root of 812 is 812. Okay? But again, anytime we have two radicals the same, the answer is just that number. It's not the square root of 812, but just regular 812. Okay, we're going to use that here in just a minute. Okay, and one last thing, just a little extension of this. Okay, what if I had this one? Oops. 4 square roots of 3 times 2 square roots of 3. Okay, you can kind of think of it as doing the same thing. The big number times the big number. 4 times 2 is 8. Okay, so we're kind of done with that. And now if you use what we just talked about, the square root of 3 times the square root of 3 is just big 3. Okay, and then 8 times 3 is 24. And notice this one, the radical goes away. Okay. One last one just to finish here. 5 square roots of 2 times 4 square roots of 2. Again, I like doing the big numbers first. The big number with the big number is 20. The square root of 2 and the square root of 2, they kind of cancel out, which gives us just big 2. And 20 times 2 is 40. Okay? Now don't get me wrong. It's okay if you do the square root of 2 times the square root of 2 and write the square root of 4. Well, the square root of 4 turns into a 2, and you get there anyway. So it's just kind of a little bit of a shortcut. Anytime you have two radicals that are the same, it turns into the big number. Okay? Let's take this a step further. Can we use the distributive property with radicals? We sure can. Okay? We can distribute through. Let's do the same thing. Big numbers with big numbers. 3 times 4 is 12, and 2 times 3 is the square root of 6. If I go to the second part, 3 times 6 is 18. Now look carefully. Here's a square root of 2 and a square root of 2. The square root of 2 times the square root of 2 is just a big 2. And 18 times 2 is 36. So my answer is 12 square roots of 6 plus 36. And notice, I can't add those two things together. This has a radical, that doesn't. I can't add a square root of 6 onto something that doesn't have another square root of 6. Our answer just has 2 parts to it. Okay? Let's try this one. 5 times 3 is 15, and 3 times 2, I get the square root of 6 again. When I do the second part, it's 5, and remember there's a negative 1 there. 5 times negative 1 is negative 5, and then I have a square root of 3 and a square root of 3. Well, square root of 3 and a square root of 3 turns into a big 3. And 5 times 3 is 15. 15 square roots of 6 minus 15. And once again, I can combine those because this one doesn't have a square root of 6 on it. Okay? So we can do the distributive property. Okay, and you're going to see this quite often again where we have the same radical times itself of a square root of 3 and a square root of 3 just turn into a big 3. And then multiplied by the multiplier. Okay? Can we take this a step further? One more step further. Can we FOIL with radicals? We sure can. How about this? 5 square roots of 2 plus 3 square roots of 5. 2 square roots of 10 minus big 5. So I have some radicals, I have some non-radicals. Let's FOIL. And if you remember foiling, and obviously there's there's going to be quite a bit of work to show on these FOIL ones. Okay, we're going to do the same thing. If I multiply my first terms together, big numbers with big numbers. 5 times 2 is 10. The radical part with the radical part, I get a square root of 20. If I FOIL or distribute to the next part, big 5 and big 5 is minus 25 with a square root of 2. I go to my inside ones, these two together. 3 times 2 is 6. And square root of 5 times the square root of 10, 5 times 10 is 50. And then the very last one here, 3 times 5, and this is a big 5. 3 times 5 is negative 15 with a square root of 5. Okay, so I just multiplied it all out. Try to combine some like terms. Well, right now, it looks like all the radicals are different. Okay, well, can we simplify it at all? Let's try. The square root of 20, I know I can do 4 and 5. The square root of 4 is 2. And 2 times 10 is 20. square roots of 5. Okay? I can't do anything with the square root of 2. That one stays the same. But if you look at your factor sheet 50, the 2 on there are 25 times 2, and the square root of 25 is 5. 5 times 6 is 30 square roots of 2. And the square root of 5, that's as far as I can go, minus 15 square roots of 5. Okay? Now, hey, look at that. I think I came across something here now where I do have some like terms that I can combine. I see some square roots of 5s. 20 minus 15 is 5 square roots of 5. And then these two guys are also like terms with the square roots of 2. Negative 25 plus 30 is plus 5 square roots of 2. Okay? So it kind of takes into account that we're really going to build on these things now. Obviously, we spent today just simplifying radicals. We spent today adding and subtracting radicals, where sometimes we had to simplify them first so they became like terms, and then we combine them. And now we're going to do a little bit of multiplying first. But a multiplication turns into an addition problem, which turns into a simplifying problem, and a combining like terms problem. Okay? But we can certainly FOIL with like terms as well. Oops. I'm sorry, we can FOIL with radicals. Let's try one more FOIL problem here once. Okay? Let's pick a good one here. How about this? How about this one? The square root of 5 plus 3 square roots of 2 times 2 square roots of 5 minus 2 square roots of 8. Can we try this once? Okay, if I FOIL, if I take my first number and I distribute it, look closely. There's no big number, so I have a 2, but I have a square root of 5 and a square root of 5. The square root of 5 times the square root of 5 turns into a big 5, and then that whole thing turns into a 10. Okay? How about when I take the square root of 5 times this? Looks like I get minus 2 square roots of 40. Square root of 5 and 8 is 40. If I do my middle term here, 3 times 2 is 6, and 2 times 5 is the square root of 10. And the last one back here, I get 3 times 2 is 6, 2 times 8 is 16. Well, you may notice something about the square root of 16. The square root of 16 is 4. So this whole one just turns into a minus 24. 6 times 4 is 24. Okay? 10 can't be simplified at all, but 40 can. Again, I'm going to go back and try and simplify my radicals. 40 can be 4 and 10. The square root of 4 is 2. Okay, so what I have all together here is I have my 10. 2 times 2 is minus 4 square roots of 10. Plus 6 square roots of 10 minus 24. Okay, so a couple of places the radical disappeared altogether, and I think we have some like terms. I have 10 minus 24 is negative 14. And then these two guys are like terms also. They're both square roots of 10. Negative 4 plus 6 is 2 square roots of 10. And there we have it. Okay, and again, these two things can be in either order, just have to make sure we have the correct sign on them. Okay, so we can distribute, we can FOIL, okay, with radicals. Okay, and the last thing we're going to talk about here is the extra special ones. You're going to see a couple that look like this. What if I had 3 plus 5 square roots of 2 squared? Okay, well, if you remember, what does it mean to square something? To square something means you multiply it by itself 2 times. Okay, and again, a long time ago we looked at a little pattern, a little shortcut to this, but I'm willing to bet most everybody forgot. Easiest thing to do is to write it twice, and then let's FOIL. Okay, so here we go. 3 times 3 is 9. 3 times that is 15 square roots of 2. Then I go to my middle term and I distribute it. 3 times 5 is another 15 square roots of 2. And this is the tricky one right here. 5 times 5 is 25. But don't forget the radical part. The square root of 2 times the square root of 2 turns into a big 2. And 25 times 2 is 50. Okay? And now just like on the last problem, I think we have some like terms we can combine. 50 plus 9 is 59. And then these two guys in the middle, 15 square roots of 2 times, or plus another 15 square roots of 2 is 30 square roots of 2. And there we have it. Okay? So again, if it starts out as a quantity squared, write it twice and FOIL. Okay? Let's practice one more of these. Okay? And then we're going to call it a day. Oops. Oops. Come on here. Okay? How about this? Negative 3 square roots of 5 plus 2 square roots of 2 squared. If it starts out like that. Again, when it's squared, I'm just going to write it twice. Okay? And now let's try and FOIL this. Okay, so I'm going to take this, oops, oh shoot. So it's negative 3 square roots of 5. Okay, so I'm going to take this first one and I'm going to distribute. Negative 3 times negative 3 is 9. And then the radical part, the square root of 5 times the square root of 5 is just big 5. And 9 times 5 is 45. So that first term turns into just a regular 45. Then I take it times this one. Negative 3 times 2 is negative 6. The radical part, square root of 5 times the square root of 2 is the square root of 10. Okay? Then I go to my middle term right here. 2 times negative 3 is negative 6. 2 times 5 is another negative 6 square roots of 10. And then I go to the last part. I'll be really careful here again. 2 times 2 is 4. But the square root of 2 times that square root of 2 turns into a big 2, which turns into an 8. 4 times 2 is 8. If I combine like terms, 45 plus 8, those are like terms, that's 53. And these two guys here in the middle are like terms as well. Negative 6 square roots of 10 minus 6 more is negative 12 square roots of 10. Okay? And I'm just going to run this in my head real quick. The square root of 10, can that be simplified? If you look on your factor sheet, there are no black ones for the square root of 10. And there's my answer. Okay? All right, and that's where we're stopping today with day number 2. Multiplying radicals. Again, one thing to remember, big numbers with big numbers, and multiply the radicals with the radicals, and then simplify when you're done. All right, thanks for tuning in.